We're now about to do some extremely important things, mixing algebra and geometry together. The subjects are truly not supposed to be separated anyway, but please do not ignore the geometry. It's going to be extremely key for what we're doing for the rest of these slides and then what we look at next time as well. So recall the picture of FOIL. So P plus Q times R plus S equals PR plus PS plus QR plus QS. So notice the P plus Q, you've got this, stick of length P glued to a stick of length Q, but that's what addition was. You've got R plus S, a stick of length R, stick of length S glued together, and then we create a rectangle with a side length of P plus Q and a side length of R plus S. And that whole area, we could split it up into 4 smaller pieces and just account for each of the pieces separately. You'll see those individual smaller 4 areas labeled directly inside those rectangles. Okay, so this is extremely important moving forward. And in fact, just to make sure we understand with some smaller example, let's just do a picture of x times x. Right, so think of we need the height to be x and we need the width to be x. That looks like this, right? And so when you do x times x, what's the times for the area? And x times x is x squared. Ha! Think about that name even, right? Like normally it's the area of a rectangle, but when the side lengths of the rectangle are all the same, this is called a square. And in fact, this is why this thing is called x squared. When we say x to the 2, another way to say that, our short way that we often say it is x squared. Why use the word squared? It's because that happens to be the area of a square where the length of the side is the base. Is this x here? So this phrase x squared doesn't come out of nowhere. X squared is our fancy terminology for x to the 2 because x to the 2 is the area of a square with side length x. So it's x squared. Let's draw x plus y times x plus y. So in my picture, because it was uncertain for sure, I just drew x to be a stick that's a little longer than the stick y, but I have x plus y going across, and then I have x plus y going down, and I should create a rectangle. This actually happens to be a square, huh? X plus y, the width is the same as the height. All right, and then you see the individual areas labeled inside, of x squared and xy and y squared. Now, if we write this out, right, what's at the top says x plus y times x plus y. Of course, we could write that as x plus y quantity squared. Again, the word square, I want you to actually think about how the choice of the word squared was really chosen because of the geometry here, of this shape is a square instead of a rectangle. So x plus y quantity squared is x plus y times x plus y, and you distribute all this out, FOIL this out, expand this out, you get x squared plus xy plus y squared. If you collect like terms for the middle two xy plus xy, you get a 2xy. So in the end, you can have x squared plus 2xy plus y squared. Now look, since x plus y is drawn by gluing sticks together, let's call y the second stick. And I'm showing you that second stick in red in the picture at the top. Now, the 4 smaller regions that you see in blue all put together form a square, right? X plus y quantity squared is, and we say it this way, x plus y squared. Let's draw x plus 5 times x plus 5. So it should look like this. Instead of x plus y times x plus y, now we have x plus 5 times x plus 5. So the second stick here, this 5 right there and there, right? So we've got x plus 5 quantity squared, and if you write out x plus 5 times x plus 5, you'll get, and FOIL this out, you get x squared plus 5x plus 5x plus 25. You actually see all 4 of those terms here, don't you? Right? X times x is x squared, and x times 5 is 5x, and x times 5 or 5 times x is again 5x, and then 5 times 5 is 25. So you see the 4 terms here, and if we collect like terms, 5x plus 5x as a 10x, we end up with x squared plus 10x plus 25. Now, the key thing to point out here is that 5 is the length of the second stick. You see it in the picture, but you actually also see right here, hope it makes sense, we've got x plus 5 quantity squared. This same 5 that's the second stick shows up in the algebra. So it's x plus second stick, the length of the second stick, quantity squared. And of course, notice that the 10x we got, it only appears because we had 2 5x's, right? So there's a 5x here and a 5x there. In the picture, in the notation, 5x plus 5x, 2 terms of 5x, 10x is equal to 5x plus 5x. So here's the thing, the big square, the huge square here, I'm not talking about each of the individual 4 blue pieces, but the whole thing all put together has side lengths of x plus y and x plus y, or in this case, x plus 5 and x plus 5. And uh, you really see a square here. Yeah. So I'd like you to challenge yourself to try drawing x plus 7 quantity squared before revealing the picture, which will be shown in the next slide. Now, before drawing anything, you should ask yourself, what should be the length of the second stick? Okay, the length of that second stick should be 7, right? And so if we draw a picture, um, stick lengths of x and then 7, so glue the sticks together for addition, and again, x plus 7, glue the sticks, but we really have x plus 7 times x plus 7, so that times is the area of a rectangle. This rectangle happens to be a square, and the individual little areas are x squared, and then a 7x, and then a 7x, and then a 49. So if we write out some algebra that corresponds to the geometry, x plus 7 squared also can be written x plus 7 times x plus 7, also can be written by FOILing x squared plus 7x plus 7x plus 49, and then by collecting like terms, we can write x squared plus 14x plus 49. There are a couple important things to notice here. First, what I'd like to notice is that the linear coefficient, it's 14 in this example, by the way. Remember, that's the number next to x. 14 in this example, happens to be twice the length of the second stick. I hope that makes sense. The second stick here, 7, right, that appears in the picture and appears here in this algebra. We ended up having 7x plus 7x, and when we collect like terms, that's where 14x comes from. So I hope it makes sense in this example, but it's something that will always end up being the case, that the linear coefficient is twice the length of the second stick. Yeah, 14 is twice what 7 was. The length of the second stick in this example was 7. Right? Okay, and then the constant, you see here 49, right? That 49 in this example, that is the square of the second stick. Remember, the second stick was 7, and if you square the number 7, 7 squared, you get 49. That makes sense that we have a 49 right here in the end. It's copied from right here, and this 49 came about by when you do the multiplications, you expand this out, you FOIL this out, the 7 times 7 is that 49. Okay, these important things to notice always happen in general, and they will be important going forward.